Hi, welcome to our pre-calculus. Topic today is solving a triangle with the law of sines, problem type 2. Let's go ahead and see what is meant by type 2. So in this problem, from the triangle, we are given C. So C is given 12, A is given 34, and the angle C is given 28. You remember in the previous lecture we had angle, side, angle configuration. There was a side trapped by two angles on either side of it, and we could always make a triangle. Here we have side, side, angle. So the case that we are looking at is SSA, side, side, and angle. This tends to be somewhat more complicated than the previous one. There are various cases to consider, and the solution becomes a bit longer than what we had, but it is still manageable. Let me try to show you what is the issue here that makes the problem slightly more convoluted. Let's go to take this demo on GeoGebra. Let's see. Sorry. Here. So in this problem you see that we are trying to construct a triangle. A certain angle is given to us. Here's the angle. This angle is given. The length of this side is given. You can change it if you want. These are so-called sliders. You can play with them. The length of this other side is also given. So one side, another side, and an angle are given. The question is, what is a triangle with these configuration? So problem kind of resembles a situation where you have perhaps a crane of a certain length and then some rope or wrecker ball hanging from it, and the question is, does this thing reach the ground down here? You see in this case that I cannot make a triangle with angle 30 degrees, this side 9, that side 3. This arm is just too short. Perhaps that might remind you of those cartoons about T-Rex and so on with a tiny hand and so on. It doesn't reach down here, and therefore we cannot make a triangle with that angle. Now if I go ahead and increase this if I increase this length, at some point it cuts the line typically at two places, and then I will have two solutions. So at this extreme I don't have a solution. So here I don't have a solution because I don't get the intersection. As I increase the arm of T-Rex, it eventually reaches down there and can actually pick something off the floor or whatever it is. Now if you keep increasing it, one of them escapes from being acceptable. It goes all to the left and disappears, and then only one solution shows up. Okay, so again, so if I go toward very short hand, it doesn't reach. At some point it just barely touches the floor in front of us, and then you have a solution. Okay, so then you have to be arranging that perfectly so it works. You go past that, then there are two solutions, and then you keep going, and then one of these solutions, this one, is going to fall behind the vertex A and becomes unacceptable because the angle is no longer 30 degrees. So we start at no solutions, then there is one, then there is two, and then it goes back to one again. So many possibilities, and you want to perhaps play with this demo, get a sense of what is involved, and solve accordingly. So let's go to our problem and see what happens here. We are all doing this thing based on law of sine, so that is exactly the same as before. So let me erase these. Let me remind you of the law of sines. Law of sines was what? If you have an arbitrary triangle, angles A, B, C, sides A, B, and C, then A over sine of A is equal to B over sine of B is equal to C over sine of C. So we just put our numbers down here and see what happens. So I have my A is 34 over sine of A, which I don't know, and that is equal to my C is 12 over sine of C is 28, and that is equal to B, which I don't know, divided by sine of B. So the plan of action is, well, look at one equation here where we have three of these elements of these two fractions and sine of A missing. We can go ahead and calculate A from here. Start the problem here. If we succeed in figuring out what A is, then from angle A and C we can figure out what B is. And once we have that, then we look at this equation to find the length of the side B. Now let's see how does that proceed and where we might face some challenges. Notice that it's making room for you to say you have multiple solutions or just one solution, or perhaps saying you don't have any solutions at all. So these are all possibilities. So in problem first part of this, we have sine of A is equal to 12 over sine of 28. So I cross multiply, so it becomes 34 sine of 28 is equal to 12 sine of A. So sine of A is 34 times sine of 28 over 12. Now we go ahead and crank up that calculator that is given here, or whatever we have, and find out what this one is. Let me get my calculator. Okay, so I calculated this thing on my calculator and I'm getting 1.33. Well, sine is never more than 1. So we cannot proceed any further. I cannot find any such angle, and then I have to go with just no solution. Okay, so in this case we get that. Now let's go ahead and see if that demo can help us see this thing. So remember the following. That here the angle, we are going to try to set it at 28. Let's see if it lets us. Here's the long arm. The long arm of the law is 34, and the other one is short. It's 12. Appears to be short, meaning it doesn't make it to this side. Let's see if we can arrange it and actually see that. Might not. So our angle here, instead of 30, it was given to us as 28. Let's see. Well, I cannot adjust it accurately enough. My hand shakes. So let me just say 29. Well, it's close enough. Then B was supposed to be 34. So this was, wow. So we are going to go 34 something. So does it fit? So we are arranging it like that. So let's it doesn't scale apparently. The other one is of length 12. So I do 12. I come all the way to 12. And you notice it is not hitting the floor. Floor is down here and the thing is up there. So this is the dinosaur, the T-Rex with the too short of a hand. It just doesn't reach. So that was one way of checking and seeing what happens. Next question here, same type. We are given a different set of numbers. This one, we are given that this is 59 degrees. B is given to be 65. Oh, no, sorry. I mistook. Let's start again. So C is, this is 59. B is 65. Angle C is 32 degrees. So in this case, you see this is the, if you wish to call this the body of the dinosaur 65, that one, the arm is pretty long, almost as long as the body. So it's 59, this is 65. Chances are good that we can actually make this thing work. Now, if it make it work, it's a good chance that you are going to get two solutions. So we have to be ready for that. So we have the following. Sine of A or sine of A over A is equal to sine of B over B or sine of C over C. These are the same thing. You can put the sides on the top and the angles on the bottom, or you can put it the other way around. It does not make any difference which way you do. Just keep all of them in the same format. These are both expressions of law of sines. From here to here, just flipping them upside down. And okay, so what is it that we have? We have C and the side opposite of it. So we have sine of 32 over 59. So let's be clear that this is the angle, this is the angle, this is the side. Now this is equal to sine of B over the little b is 65. And then that comes later. So we are going to first go after the equation between these fractions where we know three of these quantities and you're just looking for the other angle. So from here we figure out that sine of B I multiply by 65 divide by 59 times sine of 32. So I'm going to do that. So I go ahead and figure out what that is. So I calculate this thing, and if I entered everything correctly, what I'm getting is 0.5838, etc. So keep a few digits of this thing. Now sine of B is equal to that. Well, this is sine of the angle B. The question is, what is B itself? And that's where a bit of complication starts. Let's just go back to lectures from way back when. That If you have the unit circle, this is your sine axis. So on your sine axis, you have a certain sign like 0.58. Let's draw in some other color. So this is 0.58. Question is, what point on the unit circle has a shadow at this location? And the issue is that, well, there are typically 2 points. Of course, if you're up here, there is no such point. If you're all the way down here, there's no such point. At these corners, there's just 1 point. Otherwise, there are 2. So there is one possibility here is the angle B is here, and the other one is that you go all the way to the other side. You remember that when we were playing with that demo, when the hand was reaching the floor, then they could reach it to 2 spots. So how do we find it? From the calculator, you find this one. The answer in the first quadrant, you get that. The second one, let's call this thing B1. The other two, B2. B2 is, well, is B1 short of 180. B2 is going to be 180 minus B2, minus B1. So I go ahead and enter this thing on a calculator, and I find out that my so I get my angle to be, so I B1 becomes sine inverse of this quantity, 0.5838. I calculate that, I get 35.718, etc. Keep more digits so that you get more of this, or better yet, do it like this. B1 is sine inverse of, that was 65, sine of 32 over 59. So put all of that inside sine inverse. Looks a bit complicated, but the advantage is that less chance of making mistake entering these things, and your calculator is going to give you the most accurate answer you can get out of that calculator. At any rate, we are getting almost 35.7. Let me just call it 35.7. So if angle is 35.7, then I can go ahead and find out what A will be. So A, let's call A1. A1 is going to be 180 minus angle C that we had and angle B1 that we found. So you are going to have 180 minus C is 32, and B1 is 35.718. We go ahead and find out what A1 is. So you enter it on the calculator, or to do by hand, and you find out is A1 is 112 point, almost 2.82, etc. And then once you have these, you can go and find little a as well. So now we have sine of A over A is equal to sine of C over little c. So I have my A, let's call it A1 that we called here, and then I'm going to get the corresponding length here, let's call it little a1. So little a1 becomes, I multiply by sine of c. Sine of c is equal to little c times sine of the angle a1, and out comes a1 is c sine of a1 divided by sine of c. So again, we need to use calculator quite a bit in this problem. So let me go ahead and enter it on my calculator. So I calculate this one also on calculator and find out 103.02 perhaps. Okay. The problem is lengthier than usual because now let's go back. We said we find the angle B1, and based on that we solve the problem to the end. We find all the corresponding entries. Next we come and say, well, remember there are two solutions to begin with, because sine of an angle equal to a number, when it has a solution, typically has two solutions in from 0 to 180. So how about the other one? Well, let's go call that B2. So angle B2 is 180 minus angle B1. B1 is 35, so this is going to be 144.282. Okay, I subtracted that from 180 and I get 144.282. Then we have to go through this process all over again. That is, come and say, well, A2 excuse me. We have the angle B2. Now I go ahead and find the angle A2. So that's going to be 180 minus C plus B2. So that's going to be 180 minus angle C, which was 32. B2 is a large angle now, 144.282. Out comes, looks like we get a tiny angle here, 3.718. Okay, now we come and say, let's find, I need to find A2. So A2, I use sine of A2 over A2 is equal to sine of C over C, and that's going to give me A2 times sine of C is equal to C times sine of A2. So A2 is going to be, again, C sine of A2 over sine of C. Just like what we had before, instead of choice 1, we have choice 2, and we have to go ahead and calculate that one also. So this one I calculated to be 7.219. Okay, so let's go back and see what happened. Law of sines, type 2, side angle. We have a relatively easy case when there is no solution. Then the way we know it is that you calculate sine of the angle, first angle you want to find. It turns out to be larger than 1, which means it's impossible, and that's it. The problem has no solutions. Many others have multiple solutions, and here you have to enter multiple answers in order. Here's an example of that. We had with the numbers that we were given, we were showing that two answers are possible, and the difficulty arises when you have the sine of the angle is calculated. You want to find the angle itself. You remember that there are two possibilities. So you have to track each of them separately, find two sets of answers, and then you're all done. There is a possibility that you come across rather extreme cases where you have barely one solution. So let's make up an example here, just like what we saw in that software as well. Let's make some nice numbers. Suppose this is angle 30 degrees and this one is, say, 10 meters long. If it so happens that the other side is 5, if the other side is 5, it just barely touches this thing at one spot, and then you just have one solution. So if you have 30 degrees and 10 and 5, what you get for the other side, first of all, the other angle is just going to be 60, and the other side is going to be, this angle is going to become 90 degrees, and what is left for this side is going to be 10 cosine of 30, which is its exact value is going to be 5 radical 3. In that case, you have just exactly one solution. Another possible extreme case is, say, a similar scenario. Say this one was 10. If you choose the other side to be larger than the side that you have, say you have 12. Okay, so it hits one spot here, and you can go ahead and calculate the angles and sides and everything, but the other side that it hits is going to be outside of the range of this angle of 30 degrees, and that solution would not be acceptable because your interior angle is not 30. Yeah, the 30 has turned into an exterior angle. So that's another possibility that you could see in some of the exercises. In that case, you have just one solution. Okay, so this was rather complicated compared to the previous cases. Side-side angle, sometimes also referred to as the ambiguous case. Meaning there could be two solutions or multiple solutions or none. Okay, until next time, good luck and God bless.